Welcome back, everybody. So you just read about Newton's second law of motion. And in order to understand what was being said there, we might need to review a few vocabulary words. Now, we spent Monday, talking about force. Force, right? Force was the energy applied to a thing, right? We talked about how gravity is a force that pulls everything on Earth down towards the center of Earth. And we talked about how everything gives out force. So this wall has a force that won't let my hand go through. My hand can apply a force to my other hand and cause motion by pushing it, by applying a greater force. So motion is the second word that we talked about together on Monday. Motion is just movement, and it happens when forces are unbalanced. Remember that? When I apply force to one side, I can make something move by a greater amount of applied force. That's an important word. Now, acceleration. We just read that force equals mass times acceleration. Acceleration is the change in velocity, or in other words, the change in speed. So if I go from 0 to 60 miles an hour in 0.3 seconds, my acceleration is that change. And we would call it miles over seconds squared. Let me write this down. I think the blue pen you see better. So acceleration is the change in distance over the change in time. And we measure it using the time, or the distance, miles, over time, hour, or meters per second. That's another way to talk about it. So we use, actually it's per second squared. So meters per second squared, or we could talk about inches per second squared if we're talking about little things. That's how we measure acceleration. So force equals mass times acceleration. Now we still need to talk together about what mass is. What is mass? And mass is the measure of the quantity of matter. I know that sounds a little complicated, so let's break it down. Basically, mass is how much of a thing you have. It's similar to weight. When we talk about weight, we talk about the force of gravity upon an object, how much it weighs, how heavy it is. But often when we think about weight, we're also thinking about how much of a thing there is. We're thinking about mass. The difference between mass and weight is that mass never changes. My body has the same mass standing here as it does in water, as it does on the moon. But if I were on the moon, where there's much weaker gravity, I would have a completely different weight. Same thing about in water. You ever notice when you're swimming and playing in water, you feel so much lighter? Your mass doesn't change, but your weight does. So weight is a variable measure, it changes, and mass is a consistent measure, it won't ever change. But in everyday speech, when we use those two words, we kind of use them to mean the same thing. So a thing with more mass is usually heavier here on Earth than a thing with less mass, even if they're the same general size. So my eraser is much heavier. It has greater mass. It's made of much more solid stuff than my whiteboard eraser, which is styrofoam and relatively light, kind of floats in the air almost, has less mass than does the eraser. We're going to look at those two things in just a minute when we start doing our experiments. But for now, I want you just to remember mass is a different thing than weight, but It's similar in its idea. A mass is how solid an object is, how much matter it has, okay? So force equals mass, how much matter a thing has, which we weigh usually in kilograms or grams, times acceleration, which we use meters per second squared to measure. If this sounds a little difficult at the moment, do not despair. It's just because it's new to you. It's actually relatively simple. The deal is, when we want to know how much force we need to move a thing, how much effort moving it's going to take, it helps to know the mass of the thing that we need to move and the speed or the acceleration we want to move it with. Then we can figure out how much force we're going to need. Like any fun algebra project, you could make any of these your variables. If you know the force you needed to move an object and the speed it moved at, you could figure out what the mass of that object was. Or if you knew the force and you knew the mass, you could figure out the acceleration that was going to be possible. People who make cars do this all the time. They talk about the force that car has, how much power it has in it, right? How many horses, the engine has, how fast the power it's capable of putting out, and the mass of the car, and then they figure out the acceleration, what's possible, how fast is that car going to be able to go. So NASCAR NASCAR race drivers, there's the word, use this bit of physics all the time. So do people who work for BMW or Ford or Volkswagen or any of those car companies. This is stuff that we use all the time. All right, I promised you some experiments. Let me double check to make sure we've got all of our vocab, that we've talked about it. Yep, I think we're good on the vocabulary. Live students, do you have questions? Are you with us? If you have questions, I want you to be chatting, typing in chat. Non-live students, you are alive, but you are not currently with us. Those of you who are watching over YouTube later, if you have questions, go to Google Classroom and type them in the comments. I will look at those comments and do my best to answer your questions. Hopefully the experiments we're about to do will clarify a little bit. So before we start with our experiments, I have one video on acceleration I want to show you that I think will make what I tried to say here a little bit clearer. So we're going to watch that one video on acceleration, and then we're going to get to our experiments. I know I keep pushing them off. Huh? Sorry about that. All right, one more video and then experiments. So I'm going to screen share with you so you know where to find that video. You're going to watch it and come back to the next segment of our video together, where we really will be doing experiments. All right, here we go. I'm going to screen share with you. This video is going to end for those of you who are watching it later, and you're going to watch the next video after you've watched the video on acceleration. Here we go. Share screen. And it was right above. Day 3, video 1, what is acceleration? So we're all going to watch that video. And then you're going to come back and see some more of me. And we're going to put all this to the test. All right, here we go.